The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome. My name is Mike Klein, and as your moderator, I will be guiding you through today's webinar entitled How RAIN RFID Can Enhance Industry 4.0. It is our pleasure to welcome you to this special joint webinar hosted by SmartTrack Technology Group, Ketrine Solutions, and NXP Semiconductors. Today's webinar will illustrate the benefits of RAIN RFID and how this contactless technology can enhance Industry 4.0. Our presenters will show you how to choose the right solutions for the right application and how to deploy complete end-to-end solution. Additionally, we will highlight a variety of use cases of how other organizations have directly benefited from the enhanced flexibility, more efficient processes, and smarter manufacturing that came with using RAIN RFID. I'd like to now introduce our presenters. First, we have Matti Mekic, who is the Marketing Director for RAIN RFID Solutions at NXP. Secondly, we have Lori Hudanen from SmartTrack Technology Group. And our last presenter, Michael Kaiser, Partner and Product Management Director at Ketrine Solutions. Before we begin, I'd also like to note that today's webinar will be recorded and will be shared with you in the coming days. We expect today's presentation to last approximately 45 minutes and have planned for an additional 10 to 15 minutes to answer any questions you may have. So we encourage you to type any questions or comments into your browser so we can answer those during the second portion of today's webinar. With that, I will happily turn this call over to our first presenter, Matti Mekic.
Hi, everybody from my side as well. As mentioned, I will first guide you through the quick agenda overview of today's presentation. What we will start with is a definition of the key terms that we will be using, and those are Industry 4.0 as well as RAIN RFID. We'll then look at how all of this fits together and where does it bring a benefit to the end users. And also we'll look into the key application areas as well as solutions by various different industries in which this is already applied. We'll also look at various transponders that are application specific, because every application has certain application specific requirements. And then we will then move on to discussion around the system integrators and their role in the overall implementation. We will also look at what are the key components of a complete RAIN RFID deployment. And then we will also look into a select few success stories that have already proven in real life deployments. And in the end, we will wrap it up with a quick summary, and we'll open up for any questions that you may still have. So with that, allow me to explain what we mean by Industry 4.0. What this refers to is basically the fourth industrial revolution. And if we look back into the history, the first industrial revolution started when people introduced mechanization and the use of water power, steam power to help them in their manufacturing process. Soon thereafter, there was introduction of assembly lines, use of electricity for various mass production. And then in the third revolution, introduction of robots and computers and automation in industrial manufacturing. Today, what we see are cyber physical systems. Not only we have robots, but also these robots communicate with each other, but also the items on which one works on are also connected and then can communicate with infrastructure around them. So that's what we mean by Industry 4.0. And in terms of RAIN RFID, RAIN RFID refers to a passive wireless technology that has a range of several read range of several meters, and it's also capable of reading items in bulk, so very many items at the same time. It already today connects billions of everyday items to the internet, and what it allows us is to identify, locate, authenticate, and engage each item. In other words, it also allows us to have data drop from the cloud like rain into the sea. That's also one of the reasons why it's called RAIN. If you look at the overall RAIN system, there are always some items involved that are then tagged, which can then wirelessly communicate with readers. Those readers normally have some software running on them, and then that software is linked to some kind of backend network. What RAIN RFID also is very much a commercial name for a technology that is behind. So there is a technology standard defined by EPC Global, as well as ISO communities, and these specific global standards that are defining how this passive wireless technology interacts is in short called RAIN RFID. So with that, I hand it over to my colleague Larry to guide us through the next portion of this presentation.
All right, thanks Mahdi. So we have often heard about Industry 4.0 and how it will change our lives and manufacturing. That has started a little bit to irritate me, and as it's not something what will happen in the future, it's something what we are already living every day. We have smart factories built on based RFID guidance. Systems have self-diagnostic features, and machines are communicating between each other. We believe that everything can and will be connected. Parts, components, containers, tools, finished products, you name it. These systems are bringing significant benefits: enhanced life cycle management, higher supply chain transparency, smart factories, and improved user experiences and services. We don't speak about expensive items anymore. Digitization of simple things enables next-gen cyber-physical systems. Next slide, please. Mahdi, could you please change the slide? Thank you. RAIN RFID can support the full product lifecycle, starting from raw material availability, on-time deliveries, improved product efficiency, and production control. Quality inspection is often crucial for advanced high-end customers who are also interested in smart logistics, customer experience, after sales, and all the way to product recycling. The key benefit which RAIN RFID is bringing to end users is online visibility throughout production and logistic processes. Next slide. RFID is used nowadays in all industries around the globe. Automotive has been a fast-growing area for smart track, and it seems that aviation is actively following that trend. Almost all leading electronic and industrial companies are using RFID and have online visibility to their processes. As RAIN RFID is used such a wide range of applications and industries, there's no one-fit-all RFID transponder. For every project, transponders, readers, and software need to be chosen carefully. SmartTrack has designed RAIN RFID products over 15 years. With the experience of hundreds of applications, we are convinced that together with our partners, we can always find the best solution to end users' needs. RAIN RFID offers a digital ID for physical item. It has small form factor and no batteries. Fast identification doesn't require line of sight, and applications cost is very reasonable also for high volume deployments. Overall, RAIN RFID offers reliable, digitized, and fully automated processes. SmartTrack, we are a one-stop shop for RAIN RFID transponders. We are actively selling over 200 different RAIN RFID products. Inlays, labels, hard tags, sensors, high temperature, and on-metal products. Whatever is needed to make our customer systems working reliably. Today, every football at World Cup and almost every car which has been manufactured in Europe is including our transponders. Just last year, 2017, we manufactured almost 2 billion RAIN RFID transponders. Industry 4.0 is not a revolution for the future. It's a revolution which is already ongoing. Now I'd like to hand over to Katrin, who's going to tell more about system integration and a little bit about few success stories. Thank you very much.
Thank you, Lauri, and also a warm welcome from my side. I'm Michael Kaiser, Director for Product and Partner Management at RAIN Solutions. With the next slides, I will continue the presentation and give you a deeper view into the role of a system integrator. A system integrator should select the following components and put everything together. First of all, the hardware is needed. RAIN RFID reader and RAIN RFID antennas are the things RAIN can offer, and we have a big bunch of different types and variations. And of course, you need RAIN RFID transponder, Lauri already talked about. The next puzzle part is the software. And here you have to take care about the business application, about the software integration, and of course, about the selected suitable IoT software suite. We call it crosstalk at RAIN. The system integrator has also to take care of the topics of professional service and has to go from the blueprint to project management and installation. Finally, he has to pay attention to the points of on-site and remote support, but also has to offer a needed training and 24/7 maintenance. Next slide, please. The first key component I want to talk about is a RAIN RFID reader. This gateway, RAIN RFID and the IT world. The key fact we want to point out is the sensitivity you need for a high number of reads. We achieve this with a new RF design and an optimized self-channel cancellation. This may be stuff for the experts. If you want to learn more about this, please let me know afterwards. The next important point is the connectivity. Through a variety of wireless and wired interface, the reader can be easily integrated in all IT networks. Here I would like to mention the 3G interface via a mobile communication network, but also Wi-Fi and Bluetooth connections. In addition, we have also power over Ethernet. This means we can supply the devices with the existing Ethernet cable. For Industry 4.0, we talk more and more about shared intelligence. For this, we have installed a computing module in the RAIN RFID reader with 8 GB of memory and a dual-core CPU, all based on a Linux operating system. This helps you to run an application directly on the device. Of course, attention must also be paid to the compliance with the standards. We cover the global standards with regional hardware versions and follow the specifications of the EPC Global Spec, Gen 2 V2. I think you are too fast. We are already with antennas. Okay, the next key components we want to talk about are the RAIN RFID antennas. The antenna for us is the first selector in the Industry 4.0 applications and must be carefully selected. The diversification plays a major role, which allows it at a bit structure into low, mid, and wide range antenna to cover the read range from a few centimeters to 20 meters. In addition, the half beam width gives you an additional option to select the shape of the beam. For antennas, it's very important to know the environmental influences. We can select antennas for indoor and outdoors. The wide temperature range of -20 to +55 degrees helps us in all applications, and a high IP classification allows the use even in humid and wet areas. In some cases, special antennas have to be selected for special applications, such as smart shelf, but also for e-Kanban systems. The selection of linear and circular antennas can also be helpful for some use cases. For even more variety, our CRI system can be chosen. CRI stands for RAIN RFID Antenna Interface and allows the dynamic modification of antenna parameters. The reader is connected with the existing antenna cable and can control these antennas dynamically. Here, the beam can be steered for direction detection, the polarization can be rotated for higher read rate, and antennas can be cascaded up to 32 times. Next slide, please. Laurie has already spoken about this RAIN RFID transponders. Here are some more key facts. RAIN RFID transponders allow the unique identification of parts with numbering and data handling. Of course, data can be read and written. For this, different memory banks can be used. The environmental factors are also play a major role. In addition to indoor and outdoor, a large temperature range is needed in a high IP notification. An also important factor is security. We can offer transponders with 128-bit AES encryption and can handle this with our readers. This we do for authentication and anti-counterfeiting applications. Last but not least, the diversity must be considered. In addition to standard inlays, there are also hard decks for a variety of materials available. Next slide, please. So, yeah, thanks. So, as I said, we are coming now to the IoT software suite, and we at RAIN call it Crosstalk. This software is an important role for the centralized middleware called Crosstalk. About this software, we can talk the next hours. Because of the limited time, I will give you a rough overview of this. Crosstalk is a link between the devices and the IT system, but also between the business events and the ERP system. The data is read from the transponders in the production processes and transferred to the ERP system according to the workflow. The single tasks are divided into so-called templates. This guarantees that the processes are stable and the same all over the complete system. You see in the slides, the pointers are bidirectional. This means the Crosstalk software can handle, on the one side, the device management for a plug-and-play device integration, and on the other side, we have a real-time data capturing with intelligent filtering for the event and the processing. All this data will be collected and will be transported to the ERP system. You can imagine that such a powerful middleware is a core element of a functioning and efficient Industry 4.0 application. Next slide, please. Here you can see some real-life pictures. Let's start on the left for the monitoring. For the device management, all components are permanently monitored. Only if all dots are green, the system runs well. In the middle, you see the template designer. And with this template designer, the processes can be defined and makes it easy to roll out to all used devices. So you can be sure that you run all readers with the same settings and instructions. And finally, on the right, the global map view gives you an overview of all connected read points and allows to see the flow of the goods and, of course, the flow of the data. Next slide, please. Now we're coming to the success story of a real-life use case, from the individual parts to shipped goods, how to produce a car and ship it. Let's start on the left. Here you see the livestock management and the lean material handling. This can be done with an e-Kanban system based on RAIN RFID hardware and software. For stock management or the handling of returnable transport items, very often forklifts will be used. We'll have a look how does it work. At the assembly line, we have to cover high complex procedures. How to track and trace the parts in a lean production will be shown. After the car is finished, we will have a look at the supply chain and the logistics. This example stands for many others and should only show the possibilities that modern RAIN RFID systems allow. Next slide, please. So the success story starts with a livestock management and an e-Kanban solution. The returnable transport items with the needed screws, bolts, and nuts are detected in boxes directly in the shelves. For this purpose, the highly selective antennas, here you see in green, are connected to the RAIN RFID reader. Each compartment is monitored by one antenna. Up to 32 antennas can be connected to a reader, and so you can follow the flow of the boxes. From 1 to 5, you can find the key facts for this application. Here, I want to point out the very selective read zones with point number 2, so features, and that you don't need any shielding material in between because of this selective antennas. This eCanban system you can find in a car production, but also in other manufacturing areas, of course. Next slide, please. A well-known solution for yard management in warehouses is done by forklifts. The radar is mounted close to the fork, here you see in red, and will be connected with a terminal on the forklift. When the forklift picks up a pallet or box, the data can be read immediately and transmitted directly to the ERP system. The compartments in a high bay warehouse are also tagged, and though the goods and the location can be registered. Again, from 1 to 5, you can find the key facts. Here I want to point out, especially the interfaces for Power over Ethernet, Wi-Fi, and maybe also 2G, 3G network to optimize the coverage in the warehouse. Next slide, please. As already said, at the assembly line, a high complex process starts and has to be covered. On the one side, all material flows has to be combined here. And on the other side, the high reflective car bodies will reduce your read rate. With selective antenna, including polarization switching, and a reliable read rate can be achieved. In addition, several field bus connections like Profinet or OPCOA has to be added also. So you can see a really challenging task which has to be solved here. Points 1 to 5 give you some hints for this. Here I want to point out especially selective read zones with the polarization switching antennas. Next slide, please. More and more we see that Industry 4.0 doesn't stop in the production. In logistics and also in supply chain, the same system will be used. Here we see the entry and exit of a parking area for new built cars. You see in the beams in yellow. With this RAIN RFID system called RCSB, we can identify the cars, and at the same time, we detect the direction of movement. This will support the workflow because wrong bookings are not possible. If a wrong car passes the gate, it will be recognized, and also if it passes in the wrong direction. What we do with cars, we can do, of course, with containers, pallet, and boxes also. Of course, these are only examples, and we can handle also other Industry 4.0 application. And I'm looking forward to learn what are your requirements. So coming to the summary. So as you have seen, RAIN RFID is in use all over the globe. Industry 4.0 has happened already and is influencing all industry sectors. And of course, RAIN RFID is one of the key enablers. Our RAIN RFID portfolio reduces dramatically the complexity in such auto ID projects. And of course, the RAIN RFID portfolio will fill the white spots in Industry 4.0 applications. No overlapping with the modular concept. Use what you need. Our RAIN RFID portfolio enables a fast with lower risk. Become a member of our attractive partner model and your life gets easier. So I think we are done. And now we go to the questionnaire, isn't it?
Yes. Thank you, Michael. Yes, so now that concludes our presentation. I think we wrapped a little early today, but if we have any other questions from the audience, please go ahead and type that into your browser and we'll be happy to answer those now. No questions? We do have a question here. Question here is, are there any universal UHF readers?
So I think it's a question for me. Universal readers in case of universal use for different application, we can say yes, because the selection will be done with the antennas. So we can have very small read ranges, we can have very big read ranges, can have very complex systems based on the readers, and of course also all over the globe, yeah, because there's a standard which we have to follow, and in each region we have a special hardware version to run with and for the type approvals. Maybe this will answer the question.
So as a follow-up or maybe a clarifying point, they're asking, one reader can read any kind of UHF tags?
Of course. So if the tags are RAIN RFID tags based on the specific standards we have talked about, then we can read this, no doubt about this.
Great, thank you.
But you have to know there are other other RFID systems also available on the market.
Perfect. Another question, how do we achieve 100% readability?
A good question. And I think my colleagues will give you the same answer. Of course, it's needed to have the highest read rate to cover this requirement. But very often you can handle this also with the intelligence of your system. Yeah. So if something is missing, it's a matter how long does it take to get this final data back. And with RAIN RFID, it's easy to get because of the big read range. With RAIN RFID, we cover 95 to 99%. Yeah. And the rest has to be solved with a powerful software tool that you find out where are my missing gaps, where are my white spots to close the gap to 100%. Again, it's hopefully the best to reach 100%, but if not, the powerful system will help you with this problem.
Great. Another question.
And maybe if I continue about that, so this is Lauri. So 100% reliability is often needed in automotive and pharma industry, and that's the reason why we highlighted the need system integrator and also the transponder manufacturer to have every component optimized for the application. That has been the key thing to achieve close to 100% read quality in the demanding applications.
Okay.
I think the simple answer to this question would be, tuning and optimizing. You will probably, if you take off-the-shelf components as they are, you will reach, I don't know, maybe 90% readability. But then by adjusting the type of antenna, maybe, or the position of the antenna, or the power on the reader, or designing a slightly different antenna on the tag, you are then able to reach the maximum possible performance.
Okay. Next question. With regards to cascading of antennas, can this be done through wireless tech?
Would you be so kind to repeat the question? It was a noise on the line.
Yes. So cascading of antennas, can this be done through wireless tech?
So the transponders are always wireless. The point is we cascade the antenna via the existing antenna cable. This will do with a so-called daisy chain system. So we have an input and an output for some special antennas we can do it, and then we cascade the antenna in a row. First, the first antenna will be activated. We can read everything on this, and if the transponder is in front of this antenna, we can read this. If the transponder is moving along this daisy chain, of course, we can also get the feedback on each position of these antennas. This helps you on the one side to identify, but also to localize where was my reading done.
Okay. Next question. Is there a dual band or a product which has, say, RFID and BLE together?
I think this is a question for the tech manufacturers. I think there are first ideas to do so. I have seen no final products up to now, but I think this could be a good option for a transponder in the future, that we have to combine Bluetooth and RAIN RFID as the same device. Already now we have a combination of different technologies, for example, MIFARE and UHF on this RAIN RFID on the same transponder, but maybe Lauri has some answers for this.
Yeah, we are developing and designing lots of special products. At the moment, we don't have RAIN RFID together with BLE, but I don't see that to be impossible. So if there's a need for that, we need to think about how to design that for you and for the use case. But I think that's doable. That should not be a problem.
Okay. As a follow-up to a previous question, how could duplicating of data reading be avoided?
The important question. The point is always, is it possible to prevent all the cross readings and double readings? I think no. The point is the system has to overcome this problem. As I said, we have powerful CPU power with shared intelligence. Here we can select and format the data. And of course, here we can skip double readings. So such a read of a RAIN RFID transponder takes about 10 milliseconds. So when you pass such a gate, you will have a few hundred, a few thousand read results. And then this CPU on the reader concentrates the read result, skips double reading. And if you talk about cross reading, you have to think about your workflow. Of course, if you read only physical wise, you have two reads and you don't know which one is which one. But if you have a clear workflow, and that's why the templates are so important, you know this data belongs to this workflow, and then you can skip the wrong ones. Yeah. So we do it, for example, for detection direction, where we analyze the movement of the goods, and with this, you can imagine we get a lot of wrong read results, which doesn't belong to my workflow. And a powerful middleware has to live with, has to handle this, and has to skip the unwanted and the cross reads for this.
Our next question, for the Industry 4.0 market, what is required an IC specification as a UHF tag? Example, memory size or security or EPC global session time as IC?
So if I understand the question correctly, there is no, the answer is that there is no one size fit all. This depends on the use case that the customer wants to implement. For example, if you rely solely on a backend system to track or to keep track of the data related to a product or part that you're tracking, then a serial number or the EPC number on the tag is sufficient. You only identify the tag, and everything related to the tag you store in the backend. If, however, you also want to make sure that you can store certain data related to the tag on the tag itself, then you need user memory. How much user memory, again, depends on how much data you want to store and what is the relevant data. Is it expiry date, or is it the manufacturing source? Is it the path it took, etc. And then if you also want to ensure security, or if you want to ensure authenticity of a particular part. If you think of a safety relevant part that goes into a vehicle, you want to make sure that it only comes from a trusted original source. So in that case, you not only want to identify a part, but you also want to check whether this part comes from a original reliable source, whether it is authorized to be built in that final product. And that's where you then would need authentication. So the answer to the question is, it depends on the use case and the requirement of the end customer.
Okay, next question. What is the optimum range that can be achieved, and what is the tag operating frequency?
Okay, let's start with the last part of the question, the used frequency. We have different frequencies all over the world, but more or less it's a band between 860 and 930 megahertz. Yeah, and as I said, in different regions, in different areas, frequencies to follow. But the good answer is that the transponders are broadband, so it's no problem to use a system in Europe with 868 megahertz to write some data down, to send this transponder, including the pallet, the box, or whatever you ship, to US, and to read out this information within transponder within RAIN RFID reader, which run with 902 to 928 megahertz. So this is no problem to do so. And sorry, I forgot the first part of the question. Mike, can you please repeat?
It was about the read range, if I remember correctly. I think normally the maximum read range in the real life application is somewhere around 10 meters. Theoretically, you can reach a bit more than that, but in the real life, you are quite often between 8 to 10 meters.
Yeah, that's lovely, thanks. The point is also what is a needed read range. Yeah, we have talked already about cross reading, and the bigger your read range, the bigger is the risk of have such cross reading. And I gave always my system integrators the advice: please start with the lowest possible output power, that you have a small and well-defined read zone. And maximum read ranges is may helpful for some special application, but in the most use cases, it's helpful to have a small and well-defined read zone.
Okay, next question. In the case of the cascaded antennas, what is the maximum length that can be achieved between the antenna and reader with regards to the actual cable?
Okay. So of course you have to take care for the loss of the cables and the antennas when you cascade this. As I said, we have an input and output, and between this input and output, you have a loss of signal. And if you cascade, it gets down. So with our system, where we have an feeder cable of 3 meters, we can cascade up to 8 antennas with a jumper cable in between from 0.5 meter. So this gives you a total read range, total length of the cable up to the last antenna about more or less 10 meters. If you have to cover longer cables, then you have to cut, then you have to reduce the cascade. Otherwise, the last antenna will not have the proper power, and your read range can be too small.
Okay, next question. Is the read speed of cards defined in the actual specification? Is a reader forced under spec to read 100 tags per second, or is it something that is led up to the final application?
Of course, it's always a matter of how many data we should read. Yeah, and this is the first thing which influences the read speed. If you read more data, you will have to read longer. And of course, our readers can handle different kind of profiles. This profiles means the data speed from the transponder and to the transponder, and we can increase the data speed to do it faster. Yeah. So as I said, the typical rate is that we read 96 bit in about 10 milliseconds. And if you have to read a few hundreds, We can address a smaller address room to have a faster transmission, or we can increase the data speed to reach this. Yeah.
I would also like to add that this, in addition, depends on the environment in which you're reading these tags. You know, if you have, I mean, if you just hold kind of loose 100 tags in front of the reader, that's let's say easy scenario. But if each of those tags is then attached to an item, depending on the size of the item, depending on the material the item is composed of, depending on the orientation of those antennas, etc., all of those can play a factor. That is why, as mentioned previously, the 100% read range in most cases will require some tuning or optimization, and that's where partners like Katrine, SmartTrack, and NXP can come in handy to help achieve the fastest possible, the highest possible read rate.
Okay. Another question. Are there any current RFID applications in India?
Absolutely, yes.
In India is a big market for RFID. There are lots of applications there, starting from logistics and also transportation and road tolling.
Okay. Going back to the read range, does this remain the same even if there are more obstacles in between?
Yeah, it's more or less the same because it will be defined by the antenna beam. If these obstacles are metallized or liquid, of course, we will have an influence. Yeah, so we will have reflections, we will have interference. That's why it's so important that the system integrator has to adjust, has to select the antenna and has to adjust the antenna in a proper way to have always a well-defined read zone. But you are right, if metal or liquids or some other stuffs, also people are in between, it could influence this read zone. And this has to be checked and installed very well.
Okay, next question. Can a single reader be used for different frequencies in a single process and with different antennas?
So our readers has up to 4 antenna ports, and you can connect to all these 4 antenna ports different antenna types. So a low range antenna with a wide range antenna in combination, or whatever you want. And each antenna will be addressed, will be enabled separately. We have talked about the different frequency range, yeah. And for example, in US we have up to 50 channels, and these channels can be used all over US with the FCC band. If you want to have a global reader which fulfills all the frequencies all over the world, I think this is not possible. And of course, this is not in our focus, because we want to optimize the reader for a certain area. And other with mobile phones, which you carry around the world, readers will be installed at a fixed point and stay forever at this point. That's why we prefer to have a well-defined hardware design to optimize this read range in these areas.
Okay, next question. What is the maximum humidity in which a tag can be read?
I can give you the question, what is the read range you need? Of course, humidity will reduce the read range, yeah, because of humidity, yeah. But maybe Laurie has some experience with this about humidity and read range. I know this will be an influence, you will have a reduced read range, but I have no exact figures for this. Laurie, do you have something for this?
No, we need to, if it's high humid environment, we need to protect the product well. So we need to check the IP classification for the transponder. But then we need to be to support the application and check that the needed read range is achieved in the environment. So it's very tricky to say that just based on the humidity, but most of the cases it's doable. It has influence, but that can be taken care of with the correct tag selector or transponder selection, and also with the correct reader.
Okay, next question. With regards to the reader, can you clarify how it's able to read multiple tags at the same time? I had heard that RFID readers read multiple tags simultaneously.
Yeah. The point is, and the standard gives us the rules for this, that we have point-to-point. So for example, if I have 100 tags, the reader has to separate this 100 tags and to communicate with each of these tags separately. So from one reader to one tag at the same time, and not with separates. The point is that this process is so fast that it looks like that we talk with all the transponders at the same time. The good news for you is that the standards, that the reader take care for this separation. You don't have to make any installation. The reader will detect if it's one tag or 100 tags and will adjust this for these numbers. And of course, the communication is always one reader to one transponder at the same time.
Another reader question.
And in the application,
go ahead.
If I just make a comment, so what the person asking the question has stated is basically correct, that indeed, if you take a real life application example, if you have a pallet, and pallet carries 10 boxes, and each of the 10 boxes you have 10 items, all of these 100 items can go through a kind of a portal where antennas are to the left and to the right, and in the time that the forklift needs to drive through that portal, which is maybe a second or 2 seconds, so a very short period of time, it will read all of them in that period. As Michael mentioned, it will not talk to all of them simultaneously. It will talk to each one separately, but it is only taking 10 milliseconds or so. So it looks like it has read everything in a single shot, but in essence, it only read everything very, very fast. And this is enabled by the anti-collision protocol or anti-collision specification that's found in the protocol definition.
Okay, next question, still on readers. Is there a way to minimize blind spots within the reading range?
That's a good question. The blind spots are caused by a multipath transmission. Yeah. So when you build up such a read zone and you are in free space and have no metal around, you have a really well-defined shape of the antenna. Looks perfect. But this is not real life. In real life, we have metal, we have reflections, we have reflection from the ground, we have reflection from metal parts, from the gantry or whatever is needed, or from the car bodies. And then we have a multipath transmission. This is physics. And this means that we have at some points an overlapping of two signals. And maybe you remember about your physics in school time, when you have two signals with a phase delay of 180 degrees, these both phases will be delayed. Yeah. If you have a chance to overcome this problem, you will have a fixed read hole at this position. And also, if you increase the power, you don't read anything. What we can do for this, and this I mentioned before, is we have such polarization switching antennas. And with this polarization switching antennas, we change a little bit the phase of these both signals, only a few degrees. But this means we move this read hole in this area, so we can't kill these read holes. They are physics, as I said. But what we can do is we can move it. So we read the first time, and then we move all these read holes a little bit, and then we read a second time. And then it could happen that a tag, which was first in such a read hole, is now readable. We have made some tests especially for the automotive industry, with such a use case, and we can increase the read rate from 85 to 90% for a standard application with this polarization switching antennas nearly to 100%. Yeah. So this is a stuff for experts. If you want to have more details about this, please let me know after the webinar, and we can talk about.
Another reader question. Which readers are suitable for cold storage applications with GPRS connectivity?
Okay. Cold store, this means deep temperature. The question is, are the antenna in this area or only the reader also? Yeah. So as I said, our readers run from minus 20 degrees, yeah, and can handle this temperatures. If the cold storage is much deeper, we have to think about how we can handle this. For example, that we have the antenna outdoors or outside of this storage area, and only the antenna inside.
So Michael, so you mentioned that the reader should be outside of the cold storage and only bring the antenna inside, so to ensure that we are working in a correct temperature.
Mm-hmm.
For any further questions, where should we direct audience members for contact information or further information?
I think we can share our contact details, and then you can contact directly NXP, SmartTrack, or CutRAIN, and we can share the questions and answer to you together.
Of course.
Okay. In a follow-up email when we share the recorded presentation, we'll also include some contact information for everyone to follow up on any specific questions. And are there any other technical questions for our panelists before we close this webinar? I think with that may be perfect timing. I'd like to close this webinar. I'm sorry, do you have something to say?
No.
Okay, sorry, I thought I heard something. I'd like to close the webinar today by thanking our presenters, Matti, Lori, and Michael, for today's information. And on behalf of all of us, I'd also like to thank our audience for participating in today's webinar. I had a lot of great questions today. And with that, again, I will be sharing the recorded presentation in the next couple days for those who are interested in watching once more. With that, thank you and goodbye.